Hey guys, it's Spiral Review for Spiral 10. We're going to start with doing some completing the square stuff. Alright, first up we've got a problem 2x squared plus 14x minus 2 is equal to 0. In order to complete the square, first thing I might do is add 2 to both sides and then divide by 2. Leave me with x squared plus 7x is equal to 1. Okay, next up I'm going to split up my middle term, and I've got x squared plus 7 over 2x plus 7 over 2x. That's equal to 1, and to that I'm going to multiply those things together, square that middle term split up. I'm going to add 49 over 4 to both sides. Okay, my left side I'm going to factor, and that's going to factor into x plus 7 over 2, quantity squared. And the right side, 1 is the same as 4/4. So that's going to be 53 over 4, because 49 plus 4 is 53. Take the square root of both sides. We get x plus 7/2 is equal to plus or minus the square root of 53 over 4. The top of that can't be reduced. However, the square root of 4 could be written as 2. Okay, and finally we can get x is equal to negative 7 over 2 plus or minus the square root of 53 over 2. That's a terrible 5. That's not really any better. Okay, that's it. Next problem. 6x squared minus 24x plus 2. Again, I'm going to subtract 2 from both sides and then divide by 6. Leave me with x squared minus 4x is equal to 1/3. Split up my middle number. So we get x squared minus 2x is equal to 1/3. And from there, I'm going to add 4 to both sides, because I'm going to multiply negative 2 times negative 2 and get 4. I know that 4 is the same as 12 over 3. I need common denominator to add things. So this is going to end up being 13 over 3 on the right side. And the left side is going to factor into x minus 2, quantity squared. Square root both sides. And I've got x minus 2 is equal to, and nothing is going to reduce here, plus or minus the square root of 13 over 3. Finally, x is equal to 2 plus or minus the square root of 13 over 3. If you're feeling a little bit extra punchy and you'd like to rationalize that denominator, you don't have to, but this is going to turn to x is equal to 2 plus or minus the square root of, and I'm going to multiply top and bottom by square root of 3. So square root of 39, and on the bottom we're going to divide by positive 3. Next up, we're going to be solving by square roots and dealing with some complex numbers. All right, I'm going to zoom in so I can get some better space on this. I've got 9x squared minus 100 is equal to 0. I'm going to add 100 to both sides. 9x squared is equal to 100. And divide both sides by 9. I get x squared is equal to 100 over 9 square root. X is equal to plus or minus square root of 100 is 10, square root of 9 is 3. Second problem. 15x squared plus 60 is equal to 0, minus 60 to both sides. We get 15x squared is equal to negative 60. Divide both sides by 15. X squared is equal to negative 4. Square root. X is equal to plus or minus the square root of negative 4, which is plus or minus the square root of 4 times I, which is plus or minus 2 square roots of I. I'm sorry, 2I, not 2 square roots of I. All right, next up, let's add 4 to both sides and then divide by 5. So we get x plus 1 squared. 25 divided by 5 would be 5. Take the square root of both sides. X plus 1 is equal to plus or minus the square root of 5. Minus 1 to both sides. X is negative 1 plus or minus the square root of 5. Next problem, we've got to deal with some complex numbers. And first up, I've got to do a whole bunch of distribution. I'm going to start by distributing the first two, then whatever I get, I'll distribute to my end things. So we've got 2i. We've got minus 6i squared. We're going to have minus 1 and plus 3i. 6 plus 11i. Okay, that's going to reduce. So 3i and 2i is going to be 5i. Minus 6i squared is going to end up being plus 6 because I squared is negative 1. Plus 6 minus 1 would be 5. 6 plus 11i. Okay, do some distribution again. We end up with 30i plus 55i squared plus 30 plus 55i. I'm going to combine my I pieces. That's going to be 80i. 55i squared is really negative 55 plus 30. My numbers are going to combine to get negative 25 plus 80i. Part B. We've got to multiply by the conjugate at the bottom. That means we're looking at 2 minus 5i. 2 minus 5i. I'm going to do this multiplication out. 7 times 2 is 14. 7 times negative 5i is minus 35i. Negative 3i times 2 is minus 6i. Minus 3 times minus 5 is plus 15i squared. On the bottom, we get 4 minus 10i plus 10i minus 25i squared. All right. On the top, we've got negative 35i and negative 6i. That's negative 41i. 15i squared is going to be negative 15 plus 14 to be negative 1. On the bottom, my I pieces cancel out. And negative 25i squared is going to be the same as positive 25. Positive 25 plus 4 is 29. Finally, we've got an absolute value of complex number. We defined this as the Pythagorean theorem. So we've got to find 9 squared plus 40 squared. And that's going to turn out to be 81 plus, 1600. Is that 60? Yeah, 1600. 1681, which, if I'm not mistaken, should come out to be 41. For 4b, I'm going to start by getting everything onto the same side. I'm probably going to add 5x squared to both sides, giving me 8x squared. I'm going to subtract 5x from both sides, giving me minus 11x. And then subtract 3 from both sides, minus 3 is equal to 0. First thing I might do is to try to see if this is factorable. I'm looking for things that multiply to negative 24 and add up to negative 11. If it was positive 24, that would be okay. And otherwise, I think this is not going to work for us. So I might, since these are not pleasant numbers, jump to the quadratic formula where a is equal to 8, b is equal to negative 11, and c is equal to negative 3. So we get x is equal to negative 11 is 11 over 2a, so that's 16, plus or minus the square root of b squared is 121, minus 4 times a times c, so minus 4 times 24, which is going to be 96, but it's plus 96, also over 16. If we simplify this a little bit further, that's going to be 11/16 plus or minus the square root. 121 plus 90 is 211 plus 6 is 217, and that's over 16. I don't think that's reducible. For the B2 number, which is 2 minus 6i over 9 plus 5i. I'm going to multiply the top and the bottom by the conjugate of the bottom, so 9 minus 5i. 9 minus 5i. On the top, that's going to be 18 minus 10i minus 54i plus 30i squared, which we know is really minus 30. Which means that we get 18 minus 30 is negative 12. Negative 10 minus 54i is minus 64i. On the bottom, 9 times 9 is going to be 81. Minus 45i plus 45i, and then minus 25i squared, which is really plus 25. So we're looking at 81 plus 25 is going to be 116. And my negative 45, positive 45i cancel out. My final answer is this lovely fraction right here. For problem C2, we're taking the absolute value of the complex number 7 plus 24i, which is defined as the square root of 7 squared, plus 24 squared, which is going to be 625, the square root of which is 25. All right, next up, we're looking at a quadratic model. And I've got to first write an equation for this. And to do that, I'm going to use my equation. That's up here. And here we know some stuff like my v sub 0 is going to be my initial velocity. And my h sub 0 is going to be my initial height. Okay, first thing I notice is that my initial height is going to be 22 feet. And if it falls out of the tree, that doesn't mean it's being pushed or thrown. That means that my initial velocity is going to be 0. These are really important things to keep in mind. So if we're looking at an equation, I'm going to have my height is equal to negative 16t squared. Again, I'm really just copying this thing from up there. V sub 0 is 0, so plus 0t, and then plus 22. And I'm done. My equation is done. It's fine complete, and I don't need to do anything else with that. Okay. After how many seconds will the apple hit the ground? Okay, so I know that this thing, there's my tree. It's going to go like this, straight out, or more or less straight down. Here's my branch, and there's my apple. Okay, just so I have an idea of the shape of this graph. It's going to hit the ground. Okay, hit the ground means that my height is going to be 0. Negative 16t squared, 0t I don't need to include, plus 22. To solve this, I'm going to subtract 22 divided by 16. And I've got 22 over 16 is equal to t squared. I'm going to take the square root of both sides. And I get t is equal to the square root of 22 over 4. And negative the square root of 22 over 4. This answer doesn't make a heck of a lot of sense. That'd be going back in time if time is a negative number. So I'm going to eliminate that as a possibility. So in other words, that my apple is going to hit the ground after the square root of 22 over 4 seconds, or some whatever the decimal equivalent is. When will the apple reach its maximum height? Okay, well, traditionally we'd be looking at, all right, I know where it is at the start, where it's at the end, somewhere in the middle is my height. In this case, I'm literally just dropping the apple, so it's going bloop. To me, that suggests the height is maximum at the very beginning. So at time equals 0, the height would be at its max, because every other moment, that would be falling. Okay, so maximum height, well, at the start, is at 22 feet. And since it's not being pushed up into the air, it's never going to get higher than that. Next up, we've got some exponent rules. I'm going to take care of my numbers first. I tend to write this always in terms of numbers first, and then whatever the first variable is. So a squared times a squared, and then my x to the negative 8 times x to the negative 4, and then my y to the 9 times y to the 6. And now I'm going to start combining things. So 7 times 12 is 84. A squared times a squared, I'm going to multiply those, so I'm going to add the exponents. 2 plus 2 is 4. X to the negative 8, x to the negative 4. I'm multiplying, so I'm going to add those exponents. That's going to be x to the negative 12. Y to the 9, y to the 6 is going to be y to the 15, because 9 plus 6 is 15. All right, finally I've got to deal with this negative exponent here. We know that negative exponents really make reciprocals, so one way I could deal with this would be to write 84 a to the 4, y to the 15, and move that x down to the bottom, so x to the 12. Last up, we got some polynomial basics things. We've got to do some simplifying, then we got to do some sketching. First things first, I've got to simplify some expressions. This is combining like terms. I've got 5x squared minus negative 8x squared is going to be 13x squared. Negative 7 minus 13 is, negative 7x minus negative 2x is going to be negative 5x. And then 8 minus 13 is minus 5. At that point, you are done. Second one, I've got another one, so I'm going to start with my 13x to the 5th. There are no x to the 5ths in my second parentheses, so 13x to the 5th is on its own. Negative 3x to the 3rd, I have minus 4x to the 3rd there. That'd be negative 7x to the 3rd. 2x minus negative 7x is going to be positive 9x. Negative 1 minus negative 3 is going to be positive 2. At this point, there are no more like terms to combine, so I am done. We've got some multiplication to do. This means distribution. 2x times 3x squared is going to be 6x to the 3rd. 2x times minus 2x is minus 4x squared. 2x times 4 is plus 8x. Plus 1 times 3x squared is plus 3x squared. Plus 1 times minus 2x is minus 2x. And plus 1 times 4 is plus 4. I've got to see if I can combine it in like terms. I've got x squareds that are in play here and then some x's. So we got 6x cubed minus 4 plus 3 is minus 1x squared. Plus 8 minus 2 is plus 6x. And then we get a plus 4 sitting at the end. Last one of these, 3x squared times 4x is going to be 12x to the 3rd minus 3x squared plus 8x squared minus 2x, and then minus 8x plus 2. Combining like terms, nothing for the cube, 12x cubed, minus 3 plus 8 is plus 5x squared, minus 2 minus 6 is minus 8x, and plus 2. Sketching some graphs of polynomials. First thing I'm going to do is figure out my intercepts. X ints are going to have out whatever makes each parentheses equal to 0. So we've got 5, negative 2, negative 1, and positive 7. Y-intercept is what happens if I plug 0 in for each of these. And if I do that, I get 0 times negative 5, or 0 minus negative 5, 0 times 0 plus 2, 0 plus 1, and 0 minus 7. And that's going to come out to be positive 70. Okay. To my y-intercept first, that's at 70. I'm just going to mark that to show where that is. I need positive 5, 1, 2, 3, 4, 5. I need negative 2, 1, 2, negative 1, and positive 7, 5, 6, 7. I'm going to start from my y-intercept. I know I've got to go through there. I've got to have some nice smooth curves connecting these things. And I might do something that looks like this. With 4 pieces, it should make sense. We get a W as our answer. Last one. All right. First thing, let's find my intercepts. Negative 5, negative 7, positive 7, and positive 7 is going to be a bounce because it has a power of 2. So it's multiplicity of 2. Y-intercept, if I plug in 0, I've got negative for the out front, 5, 7, negative 7 squared. Ooh, nice big number. Okay, so we got negative 5. 7 to the third is going to be 343. So it's negative 1,500 plus another 200. So negative 1,700, and that's going to be plus another 20, sorry, probably plus another 15. So we're looking at negative 1,715. Someone can tell me if I did that math wrong at some point. All right, so negative 1715. I'm going to get my intercepts on. There's negative 5. I'm going to put negative 7 there. 7 there. I know that 7's got to be a bounce. So when I get to this point, I'm going to bounce off like a parabola. Okay. Might look something like this. Bounce off. And then to connect the other guys, I've got to go through that, and it's going to look something like this. That's an awesome drawing, best I've ever done. I would like to also point out that we have a negative value here, which means that we're going down at the end. I'd also like to point out that the end behavior for this, as x approaches infinity, y is approaching negative infinity for this guy. As x approaches negative infinity, in other words, we go to the left, we're also going down. Y also approaches negative infinity. And just to kind of look back at the previous problem for this guy, as we're going to the right, we're going up, so rising to the right means that as x approaches infinity, y approaches infinity. Going to the left and going up means that as x approaches negative infinity, y approaches positive infinity. So we're going up.